Hello, my name is Alejandro Covarrubias, and this is my final project for CSCI-E63. E63. This is the Big Data Analytics class, and my project is going to be a big data case study in healthcare. So I'm going to give you a brief outline of what I'm trying to achieve on this project. The purpose of the project is to do a detailed investigation or analysis on big data analytics on healthcare. I'm gonna collect data from 3 different sources. The data that I collected is from World Health Organization, from the World Bank, and from The Guardian. In order to analyze that data, I have chosen to use a Spark API, and it's really interesting that I choose to go with Python instead of Scala, for example, or to use any other resources that we learn on this course. Like, we have different Java implementations that we can do in Hadoop. We have Pig, but for this particular project, I have choose to use Python and the Spark API. So as I previously said, so a little bit more of the Spark API Python implementation that I'm using on this project. The decision of implementing a Spark API using Python is due to the fact that Python can achieve the same results as different languages in less or few lines of code. In my experience in programming, I have found that Python is really good to parse through data. Maybe if you have other problems with that you're trying in the project that you're trying to implement, you will go to another language. Like I can go on with different examples like Java, for example. And there's even you have Android, which is based in Java and XML, for example. There's such thing cannot be done with Python right now. But I think in order to parse data, Python is really good for that. And as I mentioned here, for example, a Java Hadoop implementation might take several or even 2 or 3 Java classes just to achieve the same results that I can achieve with Python for this particular problem, for just parsing through data through CSV files and through JSON files. And again, Python provides just a simple and elegant script that achieve the results desired for the given problem in just a few lines. And then just D3 was a no-brainer when choosing what tool or what technology to use in order to get our visual results. D3 was a no-brainer, just because you can implement that in JavaScript, and you can do pie charts, you can do histograms, and you have all of these different visual options in order to show the results of your data. Just to begin with the analysis of the project, I have downloaded a large data set from World Health Organization in JSON format, and this data set, as you can see, has a lot of different characters that are not good, or that are not gives us no apparent results of what we're trying to achieve. You can see you have category, region, code AFR, which stands for Africa, but then you have all of these characters that really don't tell you anything about health. So this is where Spark comes in, and our Python implementation comes in. We parse through this data and we remove all the undesired characters from that data. And so the way I achieved that, I developed this script, which just is going to take the entire JSON file and parses through all the data, and is going to filter out all the undesired characters. Or in this case, as you can see here, I'm actually filtering out all the undesired words and some characters, undesired characters, from this JSON file. And you can see down here that the sample output data begins to take form, right? We can begin to see, for example, the year this data was collected, 2012, the code for the country, and numeric values, which these numeric values on this data set stands for the life expectancy of the country. So we can see how we parse through that JSON file that we previously had that was really not telling us nothing important, but as we parse through the data, then now we start to get values. We start to see tied to a particular country, tied to the life expectancy of that country, and getting more information from that data. Again, we collected more. I have collected more data from a different source, from The Guardian, and I developed another Python script to extract important data from The Guardian. I have not provided here a sample of the data set that I downloaded. You can see I have a sample of the script, and then I have a sample of the output that was generated by the script. But since I have not provided the sample data, I'm gonna go ahead and give you a quick demonstration of running this script. And so for the first script that I'm gonna demonstrate, you can see that I'm gonna parse through this JSON file, which is a huge file that has a lot of data that we don't really need. So as I previously mentioned, we only want to extract the data that is important for us. So in order to run this script, we're gonna call the script from doing Spark submit filter. I believe the name of this script is filter pig. So you can see now Spark is running and it's parsing through the script. And now our output is going to be generated here. And we can see that now this is just extracting the important data that we need. We can see that it is extracting the numeric value for each country and for each year that the data was collected for that country. So the numeric value stands for life expectancy here. Now back to our PowerPoint presentation. So we can see how this data has been generated by using Python scripts by leveraging the Spark API. And now from that data that we parse through those scripts, we can take that data, and I have developed D3 scripts using JavaScript in order to have visual understanding and visual results of the same data. For example, we can see here that the money per capita that is spent by each country on healthcare goes into this range from 0 to 4,500 US dollars. And we can see in the top the United States spends 4,500 437, and Norway, for example, spends 4,552. So we can see the top countries that spend money on healthcare. We can also see here that 78% of the countries around the world spend less than $1 in healthcare. And we can see here that only 6% spend around 2,000 and 3,000, and even less than that, less than 6% spend 4,000 and 5, and between 5,000 and 4,000 in healthcare. That's really a concern, but I guess it depends on the economic standing on each country, right? So we analyze more data from World Health Organization in order to determine the factors that affect life expectancy. So we got a big data set that was in this format, in CSV format, and we develop another Python script to parse and sort that data. And a sample of the script is shown below. And from this script, we are trying to extract the country, the diseases, and the number of deaths by country due to that disease. And once we run this script right here, we got generated sample output as below. You can see that we have extracted the country, we can see that we have extracted the disease and the number of deaths on that particular country. And for our conclusions, we can see that the money that is spent per capita is related to a life expectancy by each country, but that there is also another factors that affect healthcare on different countries due to the slight deviation of results on countries with tough life expectancy. This is, for example, referring to that example where the United States of America spends 4,000, around 4,000 in healthcare, and the life expectancy for each individual in the United States is 79, while there are other countries like Singapore, which I believe has like 81 life expectancy, and they spend less money in healthcare. So this is due to the fact that there are other factors. When we sort the values, it can be noticed from for example, the top causes of death in the United States of America are deaths related to diseases on the circulatory system. So that may be due to different factors. For example, we will have to investigate nutrition, the culture, the life routine, how people usually goes their day-to-day lives, because all of this plays a key role on all of these diseases and affects the healthcare. Right? So as I mentioned, it's just not the money spent on healthcare. There might be other factors that affect that, and Singapore is a good example because they have more life expectancy than the United States of America, and I believe nutrition and all of that plays a key role in this. Now, those were the conclusions from the research. Now, the technical conclusions, we have noticed that for our problem statement, it was more suitable to use Python since I was parsing through data, and that provided a simple and elegant script that achieved the results desired. However, for example, if we have a more complicated problem, and for example, we have an application that has to use different APIs, or we have to write and read different content, connect to database, different distributed systems across networks, it will be best to implement this in a different language. I know Java is really a really portable language that you can do all of the things mentioned above with this. There's a distributed computing with Java. You can leverage different APIs, different libraries by just importing jar files.